Hey guys, so I'm going to go ahead and start the second part of 5.3. We already did double and power reducing, so we're going to do half angle identities and solve some problems. And yeah, okay. The first thing I do want to do is give you another example, though, kind of previous material where um, some directions that you might could be given are something like this. Write the expression as one involving only sine and cosine. We had a question on the last lesson where I said rewrite them only as powers of 1, or the highest power is 1, and that's the same thing that we're doing right here, except for we only want sines. Well, okay, I just said same thing. It's kind of the opposite. I don't want any like sign of double angles or triple angles, so only sines and cosines of x. So I can have powers, I just can't have double or multiple angles. I can just have the single angle x in there. Okay? So, the exact opposite of what we're doing before. Alright, so sine of 2x, just right off the bat, I know that as a double angle identity. So sine of 2x is 2 sine cosine. So I can take care of that pretty immediately and just say 2 sine of x cosine of x. So the real issue is going to be dealing with the second part, cosine of 3x. So cosine of 3x is not one of my double angle identities because it's 3x. So what I'm actually going to do is I'm going to use my sum and difference for cosine, and I'm going to split it up as x and 2x, or 2x and x, whatever you want to say. So I'm going to rewrite this as cosine of x plus 2x. Okay, so just as a reminder, the sum and difference formula for cosine of alpha plus and minus beta equals cosine alpha cosine beta minus plus sine alpha sine beta. Okay? So we're going to apply that to this right here where alpha is going to be x and beta is going to be 2x. So plus cosine of alpha cosine of beta. So I've got cosine x and then cosine 2x. And then this is a plus inside, and this is plus minus minus plus, so if it's a plus, then it's a minus. So minus sine of alpha, which is x, times sine of beta, which is 2x. I guess I'll go ahead and put parentheses around these just to be clear. So far, the terms that are okay, sine and cosine, because it's just of x. Cosine is fine, sine is fine. Cosine of 2x and sine of 2x are both still double angles, so I need to replace them. So I'm going to have 2 sine x cosine x plus cosine x times, and here's where we're going to do a replacement. Now, truly it's up to you on cosine 2x because cosine 2x has 3 options. You can do cosine squared minus sine squared, you can do 1 minus 2 sine squared, you can do 2 cosine squared minus 1. I'll go ahead and do the first one because it's there, but it didn't really matter. The idea was to get rid of the multiple angles, and so even though I have powers here, I don't have multiple angles, so that's the goal. So I'm going to replace this with cosine squared x minus sine squared x. Okay, minus sine of x times, and then sine of 2x is again just 2 sine cosine. Now I did put parentheses around this, but technically I don't need them because this is all multiplication. So sine times 2 times sine times cosine. There's no distribution necessary here. However, there is there. So I'll go ahead and imply that I'm going to distribute those, and I get 2 sine cosine plus, that's going to be cosine cubed, minus sine squared cosine, minus, and then this is all multiplied together, so it just becomes 2 sine squared cosine. So just a reminder, that's like me asking you to multiply x times 3xy. That's just 3x squared y. You don't have to distribute the x to each of those. Okay, these two can actually combine. So I've got 2 sine x cosine x plus cosine cubed minus, now technically a lot of textbooks you'll see they'll write the lower power terms first, but I guess I was just sticking with the sine cosine. Didn't really matter that. Oh crap, I'm supposed to combine them anyway. Alright, so negative 1 of these minus 2 of these is negative 3 of these. So minus 3 sine squared cosine. And that is an expression involving only sines and cosines with no double or triple angles. Okay. Next, let's do some half-angle identities. Okay. So, just like in the previous identities that we've done, we're going to develop the formula for cosine of a half angle using our double angle identities. Okay? So, cosine of 2 theta equals 2 cosine squared theta minus 1. What I want to do is I want to solve for cosine theta. Okay? So I want to get cosine theta by itself. So I'm going to add 1. And then I'm going to, so that gets rid of that, and then I'm going to divide by 2. And that undoes that operation. And then that equals cosine squared, so I stopped for a second because I want to make sure that we're clear on this. When I take a square root, you've got to remember that there are two options, okay? The plus and the minus. Sorry, I thought I'd adjust. Okay, so I'm going to reverse order as well. Cosine theta is equivalent to plus and minus, and I'm going to go ahead and rewrite the order. 1 plus cosine 2 theta divided by 2. Now the reason why we're going to leave it as plus and minus is because we literally don't know if it's plus or if it's minus until we think about the angle that we're actually finding the cosine of. So, like we said, we want cosine of a half angle. So what we're going to do is we're going to replace theta with theta divided by 2. So it doesn't really matter. If I said replace theta with a smiley face, then put a smiley face here and put a smiley face there, okay? What I'm saying is I want, instead of theta, what if I replace this with half theta? Then this formula becomes 1 plus, let me go ahead and change the color on that. 1 plus cosine of 2 times whatever divided by 2. I'm sure you can see what's going to happen. So I'm going to replace theta with theta divided by 2. What was it? Unsuccessful. And so theta divided by 2 times the 2. You can see that those 2's will actually go away. They'll simplify out. And so here's what we're left with. Cosine of half an angle is equivalent to either the positive or the negative square root of 1 plus cosine of the angle divided by 2. And so that's our cosine half angle identity. So I'm going to go ahead and fill that in. So get your identities page and do cosine or half angle, and you can do thetas or x's, doesn't really matter, but it is plus or minus the square root of 1 plus cosine of x divided by 2. Okay? Alright, now we're going to do the same thing, only with the double angle for cosine that equals 1 minus 2 sine squared, and we're going to solve for sine. So this will go a little bit faster because it's the same process. I'm going to subtract 1. So cosine 2 theta minus 1. I'm going to divide by a negative 2 equals sine squared. I'm going to reverse. But this time I'm going to go ahead and take a second. And I'm going to divide by the negative. When you divide by the negative, you float the negative to the top. So this becomes, well, I don't know why I said that, but you can float it and distribute it or just divide. This divided by this makes it a negative cosine 2 theta. And that makes that a positive 1, and then divided by 2. So you could think of it as cosine 2 theta minus 1 divided by 2, and then float the negative to the top, and then distribute your negative. And you see how you get a negative cosine, and then a positive 1, so I just reordered it. So that means sine of theta equals plus and minus the square root of 1 minus cosine 2 theta over 2. But if I take every theta and I replace it with a theta divided by 2, then those go away, and so I see, oh, that just looks terrible. I'll just rewrite it. So sine of theta divided by 2, 1 minus cosine of 2 times divided by 2. Replace each angle with theta divided by 2. The 2's go away, and we're left with final answer. Sine of half angle. So sine of x divided by 2 equals plus or minus the square root of 1 minus cosine of x divided by 2. And you can see how they kind of mimic these identities over here. You got the 1 minus cosine, you got the 1 minus cosine. It's just 2x here, and this is square root of just x there. So, kind of interesting. Okay. Then, we'll talk about tangent. So for tangent, one of the obvious choices is to just do sine divided by cosine. So let's go ahead and do that. So the sine is plus and minus the square root of 1 minus cosine of x divided by theta divided by 2 over plus and minus the square root of 1 plus cosine of theta divided by 2. So when you do this, when you have a square root, let's say square root of 9 divided by the square root of 3. Well, that equals 3 over the square root of 3, and when we rationalize, that happens, and then that goes away, and so it's just the square root of 3. But I could have gotten that just by saying, well, the square root of 9 divided by the square root of 3 is the same thing as the square root of 9 divided by 3, because you can distribute a power when it's the same on the top and bottom. So technically that is both 9 and 3 to the 1/2 power, or 9 to the 1/2 divided by 3 to the 1/2 is equivalent to 9/3 to the 1/2. So that's just the square root of 3, and we got there, okay? So in this case, the square root of this divided by the square root of that is the same thing as plus and minus the square root of all that. So 1 minus cosine theta divided by 2 divided by 1 plus cosine theta divided by 2. When you flip and multiply, 2 divided by 1 plus cosine theta, you can see that the 2 simplify out. So one of the tangent formulas is just plus and minus the square root of 1 minus cosine theta divided by 1 plus cosine theta. And so that's our first tan half-angle identity. There are 3 of them. So plus and minus. So 1 minus cosine x divided by 1 plus cosine x. Okay. We need the other 2 though, so what we're going to do is we're going to take the identity that we just got and we're going to manipulate it. So I'm going to split it back up as square root on top, square root on bottom. Okay, so number 2. So the square root of 1 minus cosine theta divided by the square root of 1 plus cosine theta. What I'm going to do is multiply numerator and denominator by the conjugate of the denominator. So the square root of 1 minus cosine theta and the square root of 1 minus cosine theta. So let's talk about what happens. The numerator becomes the square root of 1 minus cosine theta, either interior squared, or you can think of it as the square root of 1 minus cosine theta, all of it squared. Either way, you're just going to get 1 minus cosine theta, divided by the square root. Now, when you multiply conjugate pairs, you get 1 minus cosine theta plus cosine theta. Those go away. And then minus cosine theta squared. But, as we all know, this right here is sine squared. So what we end up with is the square root of sine squared in the denominator, which is just sine. So the square root and the square cancel each other out in the numerator, or simplify out. They undo each other. So I'm left with 1 minus cosine theta, and in the denominator I'm just left with sine of theta. So that's another one, 1 minus cosine over sine. I personally really like this one because I only have one term in the denominator, and that makes evaluating your expressions much easier. So I've got 1 minus cosine over sine. And then the third option, same thing as what we did before, only we're going to multiply by the conjugate of the numerator. So it kind of just flips it around. Square root of 1 plus cosine theta. So if I multiply top and bottom by the conjugate of the numerator, 1 plus cosine theta, 1 plus cosine theta. The numerator becomes the square root of 1 minus cosine squared theta, because the difference, well, the conjugate pairs, so become a difference of perfect squares, over the square root of 1 plus cosine theta quantity squared, because there's two of them. And that right there just becomes the square root of sine squared, which is just sine. So we just end up with sine theta divided by 1 plus cosine theta. And like I said, I like the other one better because this one I have two denominators and I have to do common denominator, flip and multiply. So I like to avoid that if possible. I mean, I'm still going to flip and multiply if the sine or cosine is a fraction. But better than common denominator. Not that it's that bad, but there you go. So we've got sine x divided by 1 plus cosine x. And so there's our new identities with 5 new, and that's all we're going to do today. As far, or not, we're not done with the video, but all the identities that we're going to find. I just did that really fast. Okay. So let's actually apply it. Use the half-angle identities to find the exact value of each function. So for this one, I went sine of 11 pi over 12. Okay. Your first goal is to think about the sign, and literally I mean like the positive or the negative sign. So when it comes down to it, I am finding sine, which is the y value, of 11 pi over 12. 11 twelfths is less than 1, so when you think about where am I, we're over here, okay? So if you think about the y value, you're going up. This is going to be a positive number. This is going to be negative, but the y value is going to be positive. So straight off the bat, I already know it's going to be a positive answer, okay? Now what I've got to do is figure out what theta is, because I don't know where 11 pi over 12 is. Well, I mean I do, but I don't know the value of it like I do know the half angle. So what I want to do is just think about it like this. Sine of 11 pi over 12 is equivalent to sine of 1/2 of 11 pi over 6. So if I just take my my angle and I cut the denominator in half, or cut the angle in half, then I can say, well, half of this angle is that, right? I guess in essence what you can do is just multiply this by 2. So if you take 11 pi over 12, your angle, whatever it is, multiply it by 2, then that's the angle that if you cut in half you get it. So that makes sense. Multiply by 2, so this angle cut in half will be 11 pi over 12. Okay. So 1/2 times this is the same thing as saying an angle divided by 2. So that's the same thing as saying 1/2 of theta. Cool? So the point is that now I know what theta is. Theta is the same thing, and they're both 11 pi over 6, which I know about. So I've got positive square root of 1 minus cosine of 11 pi over 6. Now right here where I'm writing this, you could just go ahead and plug in the actual value, but I just want to go ahead and show the steps. So, all I need to do is plug in what cosine of 11 pi over 6 is. So 11/6 pi is over here, right? Now this is where you have to be careful, because a lot of people will look at this angle for whether or not the sign is positive or negative, and yeah, this one's negative, but cut it in half, and we're talking about over here, and that's a positive. So that's what we're actually dealing with. So cosine, right? So the cosine is square root of 3 over 2. I don't know if you can read that. It's really small, but you have your own. You have your own. It's okay. So at 11 pi over 6, cosine is square root of 3 over 2. So I'm just going to plug in a square root of 3 over 2 in here. All over 2. Now what we're going to do is we're going to do common denominator. So common denominator in the numerator is going to be 2. So I'm going to make that 1, 2 over 2. And then I'm going to do this. I'm going to make that over 1, extend my square root, and here's what I've got. The numerator, common denominator, 2 minus the square root of 3 over the common denominator 2, divided by 2 over 1, but I'm dividing my fraction, so I'm going to flip and multiply by the reciprocal. And so I've actually got the square root of 2 minus the square root of 3 over 4. But I know that I can split up a square root numerator and denominator, so I've got the square root of 2 minus the square root of 3, all divided by the square root of 4, which is 2. And that's my answer. Okay? So if I were to take a calculator, which of course I don't have on hand, maybe I do. this is work. Okay. I'm going to type in radian mode. So mode radian sine of 11 pi divided by 12. And I get this. And then I'm going to type in the square root of 2 plus minus 2 minus the square root of 3. And then we'll divide that by 2. And I get the same thing. So, we are correct. Alright. Now we're going to do this problem. Use half-angle identities to find the exact value of each function. So cosine of 67.5 degrees. Okay, cosine of 67.5. So 67.5, remember I said to take the angle and multiply it by 2. So 67.5 times 2. That's going to be 120, 134, 135. So 135 degrees. So this is equivalent to finding half of 135 degrees. Which I know. So, okay. Let's talk about this angle. 67.5 degrees is in the first quadrant. So everything is positive here. So as far as the square root goes, we're going to just pick the positive. Square root of 1 plus cosine of divided by 2. And the angle, remember whatever this theta is, this is the same theta. So this theta is 135 degrees. Okay, so this is going to be the square root of 1 plus, and then cosine of 135 degrees is negative square root of 2 over 2 over 2, and you're going to see that these end up creating very much a pattern that happens over and over and over. So we divide this by, or when we say over 1 and multiply it by 2 on top and bottom, common denominator, over 1, although it simplifies out every single time. Well, no, it goes away, but. So anyway, I end up with the square root of 2 minus the square root of 2 over 2, divided by 2 over 1, which means multiplied by 1 over 2, and this becomes the square root of 2 minus the square root of 2 divided by 4. Split up the square root on top and bottom. So this becomes the square root of 2 minus the square root of 2 divided by 2. And that is what cosine of 67.5 degrees is. Okay. Let's do it again. Only this time let's do tangent. I think I'm going to do all 3 since it's a video, and don't have to worry about the bell ringing. Although, actually, just kidding, the bell will ring while I'm making this video. So, there you go. Okay. First, we're going to use this one. So let's talk about tangent of 165 degrees. So 165 degrees is in the second quadrant. So it's over here. If you can see that. And cosine is negative and sine is positive. So if I do tangent, which is sine divided by cosine, tangent will be negative in this case. So I'm dealing with the negative. First, I need to figure out what the angle is. So I'm going to take 165 and, like I said, multiply it by 2. So that's 200, 320, 300, wait, 200, 330, done. Okay. So 330. That took me way too long. Okay. So I've got the square root of 1 minus cosine of 330 degrees over 1 plus cosine of 330 degrees. Lots of cosines. Always cosines. Although, we could use some sines over here. Okay, so cosine of 330 degrees. 330 degrees, cosine is square root of 3 over 2. So, we've got sorry, I just want to make sure I didn't. Okay. I've got the square root of 1 minus the square root of 3 over 3 over 1 plus the square root of 3 over 3. The common denominator in the numerator and denominator is going to be 3. So I'm going to multiply top and bottom of 1 over 1 by 3 over 3. And I'm going to combine those into single fractions in the numerator and denominator. So I've got the square root of 3 minus the square root of 3 divided by 3 over 3 plus the square root of 3 over 3. When we flip and multiply, we multiply by 3 over 3 plus the square root of 3. The 3's in the numerator and denominator simplify out. 3 divided by 3. None of these 3 simplify out. Thank you. Please don't do that. And I'm left with the square root of 3 minus the square root of 3 over the square root of 3 plus the square root of 3. And I realize I just, oh my gosh, I just did square root of 3 over 3 and it's square root of 3 over 2. That's so sad. Okay, I'm going to fix that. Rude. Dang it, that's not right. Okay, my bad. I just looked up and was like, wait a minute. I don't think that's right. Square root of 3 over 2. Over 2. Multiply top and bottom by 2. Which makes that 2, and 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 that 2. Which makes this 2. And makes that 2. Oh, dang it. Okay, we're back on track. Sorry about that, and yeah, I apologize. Okay. All right. I just said tangent was going to be negative and then forgot the negative, didn't I? I'm just killing it on this problem. So tangent is negative. Let me go back. Put the negative. Sorry, I just hit U, I guess. All right, I did go ahead and split this back up into numerator and denominator because what I want to do is technically, I mean, you're fine, that is the answer, but I want to go ahead and get to a form where I can compare it with my other answers, so I would like to go ahead and rationalize, and in order to rationalize, we're going to have to multiply by the square root of the conjugate of the denominator. So, we're going to multiply top and bottom by the square root of 2 minus the square root of 3, which is very interesting. So, when we multiply the numerator, it's going to be negative because of that. This is going to be a square root times a square root, but they're the same thing, right? So it's the square root of this times the square root of that, or the square root of this squared, which means in actuality, it's just 2 minus the square root of 3. Cool? The denominator, I'm going to multiply out, and I get, remember the square root of two things, if I have the square root of x times the square root of y, that's the same thing as the square root of xy. So, I'm going to take, it's going to be the square root of this times this, which is 4. That's going to be minus 2 root 3, and this is going to be plus 2 root 3. Those are going to go away, just like with conjugate pairs always. And then this times this, positive square root of 3 times negative square root of 3 is negative 3, which is just 1, which means my final answer is negative all of this. True? So I'm going to distribute my negative, and this becomes negative 2 plus the square root of 3. Okay. Now I'm going to use the other forms and prove that I get the same thing. Okay, so 1 minus cosine theta divided by sine theta. So the other option, or one of the other options, is tangent of 330 divided by 2 is 1 minus cosine theta divided by sine theta. So 1 minus, and I'm going to get this right, square root, oh, dang it, that's 330. Okay. Cosine of 330 is square root of 3 over 2 divided by sine of 330, which is negative 1/2. And that's from the unit circle. Square root of 3 divided by 2 and negative 1/2. And what I'm going to do is I'm going to do common denominator in the numerator and denominator. So I've got 2 minus the square root of 3 all over 2 over a negative 1/2. We're going to multiply by the reciprocal, which is going to be times by a negative 2 over 1. The 2 simplify out. I've got to distribute my negative. And so this becomes negative 2 plus the square root of 3. So there's that one. which I much prefer. And then there is the last one. So tangent of 330 divided by 2 is equivalent to sine of 330 divided by 1 plus cosine of 330. So that's going to be negative 1/2 divided by 1 plus the square root of 3 over 2. Common denominator in the denominator, 2 over 2. So I've got negative 1/2. That's going to bother me. Divide 1/2, Jennifer. Negative 1/2 divided by 2 plus the square root of 3 divided by 2. We're going to multiply by the reciprocal. So times by 2 over, no, yeah, 2 over 2 plus the square root of 3. Those go away, and I'm left with negative 1 over 2 plus the square root of 3. But we got to rationalize, so we're going to multiply top and bottom by 2 minus the square root of 3. I'm going to squeeze in here. 2 minus the square root of 3. And, okay, in the denominator, we're left with 4. Those cancel each other out, minus 1, which is, or minus 3, which is 1. So the denominator is 1, which means you don't have to write it, and then that's minus 2. And then that's plus the square root of 3. And that's the bell, so 8th period you can leave. Just kidding, because you're not here. This is really interesting to be here without you guys. Okay. So, oh, I guess I could have, concluded from that problem. From my disastrous beginning, I rose and proved that in all 3 situations we get the same answer. I think it's pretty clear that this one is the easiest. So if I have a choice, I'm going to use that one every time. Okay. But it's your preference, whatever you like to do. Alright, so now we've got this one, sine of alpha divided by 2 and tangent of alpha divided by 2. So we're supposed to find sine of the half angle and tangent of the half angle when the angle alpha is in this triangle with this leg being 6 and this leg being 8. Okay. So this is 2 times 3 and this is 2 times 4, so it's pretty clear that it's a 3, 4, 5 triangle in the form of a 6, 8, 10 triangle. So I'm going to go ahead and label that 10, which is 2 times 5. So anytime I'm dealing with the ratios, instead of doing 8/6 or 6/10, I can just do 4/3 or 3/5 because the 2's will always go away. So all I really need to do is find or use my angle or use my identities to figure them out. Sine of alpha divided by 2. So sine of alpha divided by 2. Now, in this case, sine does have that plus minus stuff going on. But unless I put it in a quadrant where you have to worry about that, this is just out in space. Everything, this is positive, that's positive, so everything's positive. So I've got the square root of 1 minus cosine of alpha divided by 2. And that's the formula. So whatever this angle is cut in half, this is just the angle there. Okay? So for this one, I've got, pretty sure I just said so 100 times. 1 minus cosine of the alpha is 6 over 10, or like I said, 3 over 5. So I'm just going to make that 3/5 divided by 2. Then we're going to do common denominator. Get closer to this. So common denominator in the numerator is 5. So I'm going to say 5 over 5. And this becomes the square root of 5 minus 3, which is 2, over the common denominator 5, divided by 2, which is over 1. And then we're going to multiply by the reciprocal. So 1/2. The 2's are going to simplify out, and this becomes the square root of 1/5 or the square root of 1 divided by the square root of 5. The square root of 1 is 1. The square root of 5 is the square root of 5. Final answer, square root of 5 over 5 for sine of alpha divided by 2. And now let's find tangent. So tangent of alpha divided by 2 is, like I said, I'm going to use the third identity, 1 minus cosine, just alpha, divided by sine of alpha. Okay? So just a reminder, the formula is, no matter whatever the angle is, if I'm cutting it in half in here, then it's just the angle inside the formula. Cool? Okay. So, using my triangle, I've got 1 minus cosine, which I figured out there is 3/5, divided by sine, which is 8 over 10, or 4 over 5. So now when I do common denominator in the numerator, 5 over 5, I'm going to have 5 minus 3, which is 2, so 2/5 divided by 4/5, and I'm going to multiply by the reciprocal. Multiply by 5 over 4. The 5s are going to simplify out, and the 2/4 is actually going to simplify as well, 1/2. Final answer is 1/2. And there we go. So if I had an angle that was exactly half of this angle, then tangent of that angle would be 1/2. Alright. Now let's do some identity verification. So practice verifying, proving identities, okay? So cosine squared of an angle cut in half is sine plus tangent over 2 tangent. Okay, so that side over there, the right side, you know, it's not as simplified as it can probably be, but I'm going to think about that. I'm going to think about what I need. Right off the bat, just, you know, because I've been doing this for so long, sine divided by tangent is just cosine, because tangent in the numerator is cotangent, and so it's cosine over sine, the sines cancel each other out. So in my head I'm thinking, well, if I were to split this up, sine over 2 tangent plus tangent over 2 tangent, I know that if I can get the left-hand side to cosine cut in half plus 1/2, because the tangents can go away, then I can just multiply top and bottom by a tangent, and I can get to there. Actually, yeah, I can get there. Okay. All right. So, I mean, I guess I could go from here to there. Okay, fine. This is from right to left. Let's go ahead and identify. I'm going right to left. Since I went in and started writing it over here, this divided by this plus this divided by this gives me cosine divided by 2. And just to clarify that, I'm going to take a second. Sine times cotangent divided by 2, which is sine times cosine divided by sine, but there's also a 2 down there. Those go away, and I'm left with cosine divided by 2. And then always plus the 1/2. Right? Okay, the reason why I was like, well, I might as well just go ahead is because I'm done. Cosine of x plus 1, common denominator 2, that is the interior of this right here. So if I were to just square this right here, then I've got this squared, right? So if I've got 1 plus cosine divided by 2, and I square it, where is it? Cosine. Okay, cosine of x divided by 2 equals the square root of this. So cosine squared will just equal that. Oh, yeah, okay. Sorry, I'm going to think that out with you over here. If cosine of x divided by 2 equals the square root of 1 plus cosine divided by 2, then cosine squared equals just 1 plus cosine of x divided by 2. So I guess what I'll do is I'll just say Yeah. So we're gonna go from here to, yeah, to equal cosine squared. Sorry. Just trying to think like what would make the most sense as far as like what to write, other than just to have this out to the side. So, if I were to take the square root and square root, can I do that? Yeah, I can do that, but I don't know if I want to. Make sure I didn't like use any magic over here. I did. Interesting. Okay. Yeah, I'll just say it is cosine squared of x divided by 2, because that's the identity. Okay. So if this, yeah, I think that's good enough. Right. Cosine of x divided by 2, or cosine of x plus 1 equals, yes. Okay. Oh, okay. And that's the step that I wanted to see. It is equivalent to the square root of cosine of x. Let's just do that. This is equivalent to cosine of x plus 1 divided by 2 quantity squared, and this, the interior, is cosine of x divided by 2. So if I square that, you can square and square root at the same time. You can't, like, this isn't an equation, so I can't like square root both sides. I can't square both sides. But if I square and square root at the same time, then that is fine. So cosine of x plus 1 divided by 2 is the square root of cosine of x plus 1 divided by 2 squared, and all of that is cosine of x divided by 2 squared, and there's my answer. Okay. But it'd probably be easier to work it the other way. So let me work it that way right quick. Left to right. And if you can make that note on your homework or whatever whenever you're doing these problems, that would be nice, which side you're going from and to. Okay, so cosine squared of x divided by 2. Cosine of x divided by 2 is the square root of 1 plus cosine divided by 2 and then squared. So that's what that is. And that is just 1 plus cosine x divided by 2. And so when I look at this right here, I need a sine plus tangent over tangent. And the clue is that the denominator has 2 tangent, right? This denominator is just a 2. So this is one of those tricks where you just kind of know what to do or kind of play around with it. I want a 2 tangent in the denominator, so let me put a 2 tangent on there and let me just see what happens here, right? So I end up with tangent plus cosine times tangent over 2 tangent. So I need a plus tangent. Check. I need a 2 tangent in the denominator. Check. I need a sine. Well, tangent is sine over cosine. So if I can just replace that with sine over cosine and then simplify that out, then I do in fact have tangent plus sine, or sine plus tangent, doesn't really matter, over 2 tangent, and we are good. I bet you can see that. Okay. Cool. One more. Verify this identity. So half angle of tangent plus the half angle of cotangent equals 2 cosecant. Hopefully this works out. And like, that's not good identity with y'all. And it wasn't even a good identity. Okay. So, tangent of half angle. I'm going to use my identities page. I'm going to go ahead and use this one, because why not? 1 minus cosine over sine. Although cotangent doesn't really matter, because I'm going to get one of the... I might use that one then, so that I have pluses. Oh, who really cares? 1, we're going left to right. 1 minus cosine divided by sine, plus cotangent is just the reciprocal of tangent, so sine over 1 minus cosine. from here, there are two different ways to take this, okay? So I'm going to talk about it in two different ways. One way is to do common denominator, so I'm going to rewrite it. 1 minus cosine over sine plus sine over 1 minus cosine. So if I were to do common denominator, then I would multiply this by 1 minus cosine, and on top and bottom, and this by sine on top and bottom. So my denominator for both is sine times 1 minus cosine. So I'm going to distribute this. So I've got 1 minus cosine, that's minus 2 cosine, and then minus plus cosine squared, plus, now sine plus sine is sine squared, over sine times 1 minus cosine. Cool. In the numerator, I've got sine squared plus cosine squared, and hopefully we all know that that's 1. 1 plus 1 is 2, so I've got 2 minus 2 cosine over sine times 1 minus cosine. You might notice the parallel in the numerator and denominator. This is 2 minus 2 cosine, which means I can factor out a 2. So 1 minus cosine over sine times 1 minus cosine. Those can simplify out. I can bring the 2 up, and that is 2 cosecant of x. And we are done. Okay? That's one way to do it. Let's go ahead and look at this other way to do it. Yeah, okay. So, I don't know if I'm going to like this way. I just kind of thought, you know, some people might want to do that. Not naming any names, but some people really like to use conjugates. Okay, so I'm going to try it out. I'm going to multiply top and bottom of just this fraction by the conjugate of the denominator over here, and we'll see what happens. So I'm left with 1 minus cosine x over sine x, plus, I've got sine, I'm going to go ahead and leave it as this, although I probably should simplify it. Okay, this right here multiplied out is 1 minus, or plus cosine minus cosine, those go away, and then minus cosine squared. So negative cosine squared is sine squared. I don't know what I said. 1 minus cosine squared is sine squared. I think I just said negative. And these, one of these can go away, so sine divided by sine squared is just one side of the denominator. So I've got 1 minus cosine over sine plus 1 minus cosine over sine, which is really just two of these. Interesting. This was only 2 cosecant. Oh, why did that become minus? That's a plus. Dang it. They're probably yelling at me. Okay. So this is a plus, which means that's a plus, which means that's a plus, which means, okay, when I add them, I get 1 minus cosine plus 1 plus cosine, because they already have a common denominator of sine. The cosine simplify out, and I'm left with 2 over sine, which is, okay. So adding these together, common denominator, 1 minus cosine plus 1 plus cosine, cosines go away, 2 over sine, which is 2 cosecant. So I guess whichever way speaks to you. And that is 5.3, day 2.